Well, then the next thing I would like to talk about is the comparator interface. And so let's talk about what the comparator is versus comparable. And so a quick overview is I'll give an introduction into comparator. We'll look at the interface declaration for comparator. We'll talk about the methods inside of comparator, and then we'll look at some examples for comparator. This should be comparator. And then we'll compare comparable versus comparator. That is some really recursive thinking, comparing comparable and comparator. Okay, so the comparator in Java is an interface whose task is to compare objects of a user-defined class when the class does not implement the comparable interface. So the general idea is this. If you have a class that implements comparable, then there's a natural ordering that can be applied to those instances. But if you have a class where there is no definition for naturally being able to compare them, then you can create a comparator object that defines how to compare those objects. So in other words, Java comparator is used when objects to be ordered do not have a natural ordering defined by the comparable interface, or there's an alternative as well. There's another reason why. When you want to order elements differently than what the natural ordering as it's defined by the comparable interface. So we can change the ordering with a comparator object, or we can define an ordering if one was not defined. So in both cases, we can specify a comparator object when you construct either a set or a map, because recall that with tree set and tree map, they can both sort for us. So comparator interface was introduced in Java 2, and it's present inside of the java.util.comparator package. So let's take a look at the interface declaration. The comparator is a generic interface that's declared in its general form like this: public interface comparator, and then it uses static typing, where inside the angled brackets would be whatever the data type or the element that we want to compare between. And so let's look at the methods for the comparator interface. There's two that we should look at. They have the compare method. So remember and again, this is what allows us to think a little bit differently. The comparable had a compare to, the comparator has a compare. And so the compare method takes in two parameters, two objects, and will return back an int value. And the int value, the rules for that for the comparator will be the same as it is with comparable. So it compares the first object with the second object, and it returns 0 if the objects are equal. It returns positive if object 1 is greater than object 2, and it returns negative if object 1 is less than object 2. So again, let's take an example to better understand comparator. Let's say we built a comparator or defined a comparator interface for the purposes of comparing countries. It might look like this: public interface comparator, and then country typing, and then it int compare, and then it would have to have this abstract method where it's looking for country A and country B to compare. So the call to com.compare A comma B will return a negative value if A comes before B, 0 if A and B are equal, and a positive value if A is after B. And here com would be a object of a class that implements that comparator country interface. So the compare method can throw an exception named class cast exception if types of objects are not compatible for comparison. And by overriding the compare method, we can change the way the objects are ordered. So for example, to sort elements in reverse order, we can create a comparator object that reverses the outcome of a comparison. That way we can have objects that have a natural ordering, and then we can create a comparator that customizes the ordering. So the comparator interface also has another abstract method, which is an equals method that takes in an object and returns back a Boolean value. The equals method defined in the comparator interface is overridden of the equals method of the object class, and it's used to test whether an object equals invoking the comparator. Here, the parameter object is the object to be tested for equality. If the object, let's call it obj, obj, and the invoking object both are comparator objects and use the same ordering, then the equals method returns true. Otherwise, it will return false. Overriding equals is not always necessary. When it is not necessary, there's no requirement to override the object's implementation. Because again, this isn't the nice thing about this equals is it's overridden. So it gives you the option to, but you can leave it to have the default value that is given inside of the object class. Okay. So the complete declaration of a comparator class that is defined in the java.util package would look like this. So here we have a public interface comparator that's using generic typing. So T is a generic type. Then we will have an abstract method that is the compare method that takes in two objects and returns back an int. And then we'll have a redeclaration, the equals method of the object class defined in an abstract way. Okay, so let's take a look at some example code of where we perform sorting of integer elements in ascending order using a comparator. Look at the following source code and let's make sure that we can understand the power of custom comparators. So the first thing we're going to do inside the source code is we're going to define a comparator class, and then we're going to actually test it out. So let's jump over to our, I'm going to close this old source code out. Let's jump over here to comparator tester 1. Okay, so I'm gonna start down here where I'm defining my class. I'm gonna create a class ascend because I want it in ascending order, and I'm gonna implement the interface comparator for integers. So we're gonna be ordering integers. And so inside the body of this class, I'm gonna override the abstract method compare inside of the comparator interface. Here's public, it returns back an int, and it takes in two objects. Here the objects will be it's got to be reference type, so capital I integer, two parameters, I1, I2. And here I'm just going to return using the natural ordering. So integer already implements the comparable interface. So I'll just use the comparable interface to compare to I1 to I2. So this is like the lazy way, just to show you how we can create a comparator object or class. Here, I'm going to go ahead and import the comparator interface. And then I'm going to tree set, which is, again, a collection that does sorting for us. Then I'm going to create a class comparator tester 1. I'm going to create a main method. I'm going to create a new instance of ascend, which is our comparator object. And then when I create my tree set instance, right? So I'm going to create a tree set to hold integers. And when I construct it, remember or recall that one of the constructors can take in a comparator object. So I'm going to pass it that comparator object that it will then use for the sorting. And then I'm going to add in all sorts of integers. I'm going to add in 25, 15, 30, 10, 40, and 50. And then again, let me run this. So while I'm talking about it, we can see. So when I add those, it naturally gets sorted so that when I use this enhanced for loop to print out each element inside of the tree set, I can see that, hey, it's all sorted in numerical order, 5, 10, 15, 25, 30, and 40. And that sorting was done using the comparator object and not the natural ordering. Okay, let's look at another example. Let's look at maybe a descending sorting example where we change the behavior. So let's write a program to sort elements in descending order using that comparator in Java. And again, we're going to have to create a class that is a comparator class. And then we'll go ahead and use that inside of a tester class that has a main method. So let's jump over here and actually look at the source code in our IDE so I can run it. And again, I'm going to run it right away here so we can look at the output and I can reference it while I talk. So first, let's look at this class descend. So we're going to create our own custom class descend, which implements the comparator interface. And we're going to use the typing, generic typing. So if we're comparing integers, then we're going to override the abstract method compare, returns back an integer, and it takes in 2 parameters. And the parameters are going to be whatever it is based off of the typing that we're implementing off of. So it's going to be integer that we'll refer to as I1 and integer I2. And here, what we'll do is we're going to make use of comparable, but we're going to flip it, right? In order to get ascending order, we're going to take the I2 value and compare it to I1. So when we were getting the ascending order, we did I1 compared to I2. Here, we'll reverse it. And now, if I wanted to, I can customize it. So I don't have to default to the comparable interfaces compared to method. I could manually check to see if I1 is greater than I2, or if I1 is less than I2, or if they're equal and return the value. But here I'm just making use of predefined implementations. Okay, so in the actual implementation of our tester here, our tester application, we're going to import the comparator interface. And that's, of course, we're doing that for our class here. We're gonna also import the tree set concrete class so that we can use it in the comparator tester too. I'm gonna create a main method. We're gonna create an instance of our comparator, which will be descend, our descend class. I'm gonna create a new tree set where I pass it a comparator object, ds, our descend object. And here I'm going to add in 25, 15, 30, 10, 40, and 4 into our tree set. And as we print out using an enhanced for loop, each element in our tree set, you'll see it's now in descending order. So the greatest value is printed is first, then 30, 25, 15, 10, and 5. Okay, let's take one more example program similar to the aboves, but where we will perform a reverse string comparison. So the last 2 examples, we focus really on integers. So let's look at something that isn't an integer, that isn't numerical. So again, in order to do this, we would have to define a class that would implement our comparator interface, where we can instantiate comparator objects or instances, and then we'll create another class that contains our main method that allows us to test that comparator instance or use it in practice. Let me collapse some of this. So here, let me go to comparator tester here. And so the first thing I want to do is look at our comparator class. So I'm going to create a new class called reverse string compare, or rev string comp. And that's going to implement our comparator interface. And we're going to use generic typing to specify it's going to be typed to string. So when we go to override our compare method in the interface, we can put that the data type will be string data types because of the generic typing. And then I'll just give the parameter labels as str1 and str2. And then I'll use the natural ordering of the comparable interface for strings just to go ahead and compare them. But instead of comparing string 1 to string 2, I'll do the same tactic I did in the previous example, where I'll use string 2 and compare it to string 1, and that'll give me a reverse ordering. So again, let me go ahead and run this. And so here I'm importing comparator because it's used right here. I'm implementing it here. So if these were 2 different class files, that comparator would be linked with this implementation. And then with this tree set, I'm importing to be able to store a collection of my strings and to be able to sort them naturally when I add into the tree set. So let's create a new instance of our comparator instance, our reverse string compare class. And then when I create a new tree set, I'm going to pass it in that comparator instance. And so this is going to be a tree set that stores strings. We're using, again, that generic typing. We're going to add into our tree set a collection of a variety of elements: cat, elephant, lion, dog, tiger, and horse. And now I'm going to use an enhanced for loop to go ahead and display that. And you'll see it is in reverse order: tiger, lion, horse, elephant, dog, and cat. And that's because by passing in a comparator instance, tree set uses that for sorting purposes as opposed to the natural order defined by the comparable interface. Okay, there's one last example. Let's take a look at an example program where we will sort an array with a group of integer elements using the comparator. Here we'll accept array elements from the keyboard and sort them in ascending and descending order. So again, we'll look at the following source code. So here we'll create two different comparators, one that is ascend array and one that will be descend array. And then we're going to create this class that'll have a main method that allows us to test that out to see just how powerful a comparator instance can be for us. So let me go ahead and get to this implementation here. Let's go to comparator, open that up. So I'm going to go ahead and import comparator for being able to define my two comparator classes. So here I'll create a comparator class ascend array that implements comparator, and it compares integers. So we're going to use our generic typing there. And so we're going to override the abstract method, returns back an int. The compare method will take in two integers, and it's going to use the natural ordering. And then we'll create a descend array class that also implements comparator on integers. And this compare method will take in two integers, but it's going to do reverse ordering. So it'll use the second parameter and use the compare to on the first. So that'll give us a reverse ordering. So let's take a look at what we're going to do here. Here, I'm going to go ahead and import in the arrays class that gives me a sort method. I will go ahead also and import some input stream readers and buffered readers to be able to go ahead and grab data from the keyboard. Here, I'll create my class comparator tester that has a main method. And because I'm going to grab things from the keyboard, I could potentially throw a couple of exceptions: a number format exception and an IO exception. So we'll just go ahead and throw those if I cause one of those to occur. So here I'll create, and this is a little preview of what we're going to be doing in Unit 3. So this gives you a flavor of how we'll learn to manage our inputs and outputs without having things like the scanner object do it for us. Here we can create a new input stream reader, and we'll look at the system.input stream. And then we'll create a buffered reader where we'll pass our input stream reader. We'll then create a new instance of a buffered reader. And then we'll send a query to the user here: how many elements do you want to sort? And then we'll read that line. And then we'll create an array of that size. And then it'll for a loop for the amount of elements. It'll ask, okay, enter a number, and we'll go ahead and enter those numbers into the array. Then we'll create a comparator instance, so the ascend array comparator, and then we will go ahead and on the arrays method invoke the sort method, which can actually take in two parameters. The first is the primitive array we want to sort, and the second is the comparator instance, the rules by which we want to sort those elements. And then we're going to display that array, and that's just a helper method here, a static helper, where we can pass in an integer array, and we just have this enhanced for loop that iterates through and prints out each element. And then we're going to do the same thing, but we're going to do the descending order. We're going to create a new comparator instance here, a DS, which is the descend array comparator. We'll call the arrays method on our primitive array using that new comparator instance, and then we're going to display the array. So now if I go ahead and run this, how many elements? Let's just do something like 3. Enter a number. Let's do like 100. 0, 1. And then here, let's look at this. So then in our sorted ascending order, it would be 0, 1, 100. And our sorted in descending order is 100, 1, 0. So you can see right in the fly with an interactive application, how we can go ahead and make 2 different comparator instances and then use it to sort our collection. And so we can use the sort method in arrays. We can use the sort method in collections. We can use a tree map. We can use a tree set. We can use a priority queue. There's plenty of reasons as to why we would want to use either comparable or comparator. Okay, so let's talk about comparable interface versus the comparator interface. Both comparable and comparator interfaces are used to sort the collection or array of elements, but there are differences. So you use the comparable interface. Comparable interface is used for the natural order sorting of objects. For example, if you want to sort employee class by employee ID, that's our natural sorting. Comparable is used to sort collection of elements based on only a single element or logic like a name. And the comparable interface is used when we want to compare itself with another object. Okay, so for the comparator, these are some considerations. The comparator interface is used when we want to perform custom sorting on the collection of elements. It gives exact control over the ordering. For example, if we want to sort employee class by name and age, we can define that custom sorting. Comparator is used to sort collection of elements based on multiple elements or logics like name, age, class, roll number, whatever. And the comparator interface is used when we want to compare 2 different objects. And then we could define an ordering that way because it gives us that kind of control. Excellent. And so that's really what I have to say about the comparator interface. And both these are definitely worth knowing if any sorting is required on your objects while they're maintained in a collection. So is there any questions that you have about comparator?